Hello everyone, welcome back to my channel. In today's video, we are going to implement a complete thesis level machine learning project titled Financial Fraud Detection using Deep Learning Autoencoder. So this project is basically highly useful for BTech, MTech, MBA, MSc and even PhD students who are working on anomaly detection, fraud detection, or financial analytics based thesis topics. So we will be implementing this complete project step by step in Google Colab without installing anything on our local system. So the step one is we have to download the data set. Okay. So you can see that I am installing the data set here, by this. And then here, instead of downloading the dataset manually from any external source, we are directly downloading the dataset inside Google Colab using this command. So this command basically fetches the credit card transaction dataset, which contains both normal and fraudulent transactions. So after running this, the dataset will automatically be available in our working directory. So now we are loading this dataset using pandas and checking the first few rows to understand the structure of the data. So the next step is installing the libraries. Okay, let me show you where I'm installing the libraries. So here you can see that here I'm installing the libraries. These include TensorFlow. You can see this include TensorFlow for building deep learning models, Pandas for data manipulation, NumPy for numerical computation, Matplotlib for visualization, and scikit-learn for preprocessing and splitting the data. So, guys, I've already run the collab. Here, I'm not running it because it will take time and I can't uh, uh, make such long video. So, I've already run the code and I'm showing you the output. Okay. So, the next step is now we import all the required libraries. We have already imported all the required libraries. Now we will import. Okay, yeah, you can see that here we am using pandas to check the structure of the data set. Here are the few rows of the data set, how the data set looks like. Okay, so now we will import all the required libraries and we will import min-max scaler for normalization, train, test, split for splitting our data set, and Keras layers like input and dense for you can see that, and Keras layers like input and dense for building our autoencoder model. Okay, so why we are normalizing the data set? We are first of all we are normalizing our data set using min-max scaler. Normalization is important because deep learning models perform better when the data is scaled between a fixed range, usually between 0 and 1. So here we are separating the input features from the target class label. So the class column indicates whether a transaction is normal or fraudulent. So the train test split I have shown you, we have done the train test split. We have to split our data set into training and testing set. This helps our this helps us train our model on one portion of data and test its performance on unseen data. So here we are using 80% of the data for training and 20% for testing. Now the next step is building our autoencoder model like I have shown you here. So this is the most important part of the project, building the autoencoder model. And autoencoder is a type of unsupervised deep learning model that is used for anomaly detection. So it consists of two main parts, encoder, which compresses the input data into a lower dimensional representation, and decoder, which reconstructs that data back to its original form. So the idea here is that the model will learn normal transaction patterns. So when a fraudulent transaction is passed, it will not be able to reconstruct it properly, resulting in a higher reconstruction error. Now the next step is training the model. So now we will train our autoencoder model. Yes. So now we will train our autoencoder model using the training data set. So we are training the model for 10 epochs. You can see the 10 epochs. I have already run it with a batch size of 32. So during training, the model tries to minimize the mean square error between the input and reconstructed output. Now the next step. The next step is you can see that the loss is getting. minimize, optimize. So now the anomaly detection. So once the model is trained, we pass the testing data through the autoencoder. We then calculate the reconstruction error, which is basically the difference between the original input and the reconstructed output. So higher reconstruction error usually indicates an anomaly or fraudulent transactions. Now we can visualize it. So finally, we visualize the reconstruction error. You can see that using a histogram. So this helps us understand the distribution of normal and fraudulent transaction based on their anomaly score. Fraudulent transactions generally have higher reconstruction errors, like you can see that compared to normal transactions. So this was a basic implementation of financial fraud detection using deep learning autoencoder. So if you're working on your thesis, research paper, final year project, literature review, or need help with data analysis using Python, SPSS, or R, you can check the collaboration details, in the description below. Here, one-to-one implementation and full thesis code is available. So thank you for the watching, and I will see you in the next video.